All right, everybody. Thank you for joining us. My name is Richard Pa, and this is the last and most interesting panel of the first day of DAC. This is the cloud panel, and we'll be talking about EDA and cloud computing. So, joining us, we have four experts. Directly to my left, we've got Aman Joshi from Western Digital. Aman is a senior director for design enablement and automation, including AI and machine learning and cloud computing for EDA, and global ASIC engineering team at Western Digital, supporting all engineering teams worldwide in acquiring and implementing EDA technologies and IP for flash control ASICs. Aman starting out at Intel in Santa Clara in design technologies in the microprocessor group, supporting Pentium. Aman has broad expertise in engineering design flows for high-end CPUs, GPUs, and NPUs. Before joining SanDisk, which is now Western Digital, 8 years ago. After an 8-year stint at Sun Microprocessor Group, Aman also worked in Silicon Valley startups and is now part of NVIDIA, Cisco, etc. Aman has a master's in computer engineering from Syracuse and undergraduate in EE from MS University in India. To his right is Mushtaba Hamid from Microsoft. Mushtaba leads the silicon and energy industry engagements for Azure. Mushtaba and his team are responsible for end-to-end product management to align the Azure technology platform, business models, and ecosystem partnerships for these industries. Before that, Mushtaba spent 10 years at corporate strategy at Microsoft, including Windows and Office products. And prior to Microsoft, Mushtaba was at Xilinx, started managing the applications team, and focused on corporate strategy. To his left is Derek McGill from Qualcomm. Derek's been an engineering IT support for 20 years, started out in the Linux help desk at TI. Over the years, he's held various systems architecture and leadership roles. He's currently the engineering cloud architecture lead and global EDA licensed infrastructure lead at Qualcomm. Derek also serves as the chairman for CLUG since 2015 and is executive director for the Association of High Performance Computing Professionals. And he's also largely responsible for the infrastructure alley that we have today. Okay? Okay. Last but not least, we have Craig Johnson from Cadence. Craig is the VP of Cloud Business Development for Cadence Design Systems. He's responsible for driving the use of Cadence products in the cloud. Since joining Cadence in 2004, Craig has held leadership roles in strategic planning, marketing, M&A, IT, and business development. Prior to Cadence, Craig held positions at enterprise strategic marketing, processor roadmap planning, and manufacturing operations during his 11 years at Intel. Craig holds an MBA and a BS degree in electrical engineering and computer science from Brigham Young University. Okay? Let's give them all a big hand. Okay. So I'll go ahead and start. The first question is that, so there's a lot of buzz around cloud computing at DAC several years ago, right? There was a lot of interest. We had panels about it, a lot of sessions. Interest waned due to concerns about security and data leakage. Has concerns around security lessened? Does the cloud now have enough of a track record to ease concerns of customers? And what has really changed since then? Think?
Hello? Better? All right. It's working. I think people are nodding. Yes. Get it closer. Yeah. Okay, so yeah, I think a lot of things have changed in many years. It was a big, definitely a big buzzword a few years ago. And we are noticing also that a lot of corporate applications have actually moved on into the cloud, and that has made our IT groups very comfortable. They also have new ways of managing security. That has also made our IT groups much more comfortable. Our IT director is back there, and he's also fairly comfortable because he can manage a lot of the, through VPC, and he can manage a lot of services. Sometimes it's even more secure than our on-prem solutions. So I think that has really helped us open the doors to try something on engineering side, to try them on the cloud.
Can you hear me? So thanks, Rich, for hosting the panel. So I think it's a two-part question. That you had a part around the concern. I think the concern around security is paramount regardless of where a job is running. So, and from a Microsoft standpoint, that is a paramount topic for us. We talk about trust, and trust for us has four components. We really care about privacy, and we focus a lot in investments around privacy, both for the organizational data, users' data. The second part is security and building security from the ground up in all our services. And the third part there is around transparency. So really making sure we've got the broadest portfolio of compliance certifications, right to audit programs that we make available to everyone. And finally, like, we also have to look ahead to what's coming next. And there's a lot of talk about AI. And we've been talking a lot about ethical AI, and we formed a set of principles and bodies around thinking through the topics on how do we think about AI questions from an ethics standpoint. But to Amal's response, over the last 2 years, we've really seen this flow towards cloud adoption. And large companies, such as Chevron, are going all in for HPC, mission critical workloads, industries across finance and healthcare. So yes, I think cloud has turned that corner around the security perception as well as the enterprise readiness perception. So we're starting to see a lot of movement.
And I think the other observation I have, we've talked to probably multiple dozens of customers about cloud over the last few years, and security was always a concern, but I think the other opportune thing now is that the things you can do with a cloud, with the amount of compute and the type of compute that's available, it's actually quite enabling to solve some of these problems with complexity and the sheer amount of data that's generated in verification and all of the other design steps. So it's a combination of getting over the hump as well as seeing new opportunities to use the cloud differently.
I think the other thing that's worth noting is that when you compare the security tools that you have available in the cloud to what you typically have available off-prem, the automatability, the API access, the ability to put firewalls in front of different services, IAM role-based access type of functionality. You don't have that kind of thing on-prem. And the ability to do that inside the cloud gives you a level of trust that you really have to have in order to break that barrier. A lot of us, the main problem with security for the cloud is that no one generates all of their IP anymore. You're buying your IP from third parties, and so if you're putting your data in the cloud, you're not just putting your data in the cloud, you're putting your third-party data into the cloud as well. And you have a duty of care to make sure that that data doesn't come out. Because in the old days, when you maybe were creating all of your own IP, if it got out, then, well, that's too bad, that's my fault, we'll do better next time. Now, if you lose that IP, it's a lawsuit fest. And everyone's trying to figure out whose fault it was. Is it the cloud provider's fault that the data got out? Is it because you have a bad architecture that the data got out? But the cloud providers give you a lot more tools to correctly put your data in without having it falling into the wrong hands. But you have to put a lot of thought into it in order to make that happen correctly.
Okay, thank you. That leads us into the second question, is that one of the other reasons that cloud never picked up for EDA last time was that, for the most part, the EDA vendors did not allow their tools onto the cloud through licensing restrictions. Also, a lot of the IP vendors didn't allow their IP to be put on the cloud, also through license restrictions. So has that changed? Are IP vendors and EDA vendors allowing customers to bring their tools to the cloud with them?
So as a customer end user of tools, it is something we have to work on. It's not by default, every deal, everything, you have to kind of work with your EDA vendors, with your IP vendors, and there's always this question of security. There's a question of who's liable in what situation. So it is still an uphill battle. It isn't like a given like you would have with a social network application or something like that, where everything is sort of available on the web. So we certainly have that challenge, and it will be easier if default comes from EDA vendors' contracts and everything just makes it enable those things more easily. And I think I heard some announcements even yesterday that more and more companies are putting the tools out there. So I'm assuming the legal background is there. So I think that's certainly always a concern for us. But it is getting better. It is becoming easier to ask for exceptions, and I think people recognize that this is much more common.
So Cadence has obviously been pretty aggressive about the cloud this DAC, and we're committed to enabling the cloud in a fashion that's consistent with how our customers want to consume it. In some cases, that means they want to do it themselves, and in other cases, it might mean they want our help. As long as the proper terms and conditions are in place, such that everyone is aware of what their responsibilities are, I think it's not going to be a limiter anymore. One of the exciting things that, if you read our press announcement, was one of the major foundries, TSMC, provided an endorsement, and they've been long hesitant to sort of embrace the cloud like that. And I think it's a sea change, and other IP providers, when consulted, are giving permission now. So I agree with Aman that it was a little bit spotty. I think going forward we'll see it become much more common.
Right, so from our standpoint, we definitely see an increased amount of interest in both companies wanting to bring their infrastructure onto cloud or start to create ecosystems where IP is shared. From a Microsoft standpoint, our job is fairly straightforward. We have to continue focusing on building this trusted, secure platform that the industry can innovate on. So for this question, I'll defer to the industry to answer how quickly the migration is happening.
Well, so the migration is not going to be happening super quickly, but I mean, I think the sea change comment that you made earlier is true, that we're starting to see more acceptance of it. And I know of instances of IP providers who they want to know how you're going to treat their data in the cloud. And so I think one of the key things that would be a great enabler for us is having reference cloud architectures that we could go and say, hey, we're using this kind of a paradigm. But there's still so much about the cloud that, the 30 years of technical debt that we have that are involved in your typical semiconductor design that don't fit necessarily immediately into the cloud. You've got to spend a lot of time thinking about how I bring that in and explain that to those IP providers. But again, like you said earlier, making sure that everyone knows what their responsibility is. But once you can demonstrate to the IP providers that, hey, I'm taking this security piece seriously, what I've seen is that they are willing to say, okay, we agree to this.
Okay, at this point, I'd like to see if there's any questions from the audience. Go ahead, I'll repeat the question.
How do you see the changes in licensing being made to accommodate this?
So the question is, how do you see changes in licensing accommodating this?
So from a Cadence perspective, our philosophy is much like, I'd say, the cloud vendor's philosophy, which is shorter term use of something carries a premium, and it has to be reasonable, and it has to fit the use case. And we've got business models that support our announcement that allow for shorter term use than annual licenses, which obviously aren't practical if you're trying to meet a project deadline that's only going to last a few months, for example. So that's our approach to it, and we'll continue to work with customers to try to optimize that for what they're trying to achieve.
Just one thing I wanted to kind of add on to that was cloud has grown up to be much beyond a pay-as-you-go utility computing model, and we certainly see customers sort of running effectively clusters in the cloud always on. And so the licensing situation should, as the industry thinks about licensing for the cloud, there's elements of traditional licensing models that still apply and will apply to the cloud, and new models such as what Craig has been talking about, where there's opportunities to innovate. So that entire spectrum will be available in the cloud looking ahead.
I mean, as a user, I would also like to see a kind of a per minute cost in cases when we need it. Suppose you have an overnight on a job that runs 100,000 or a million jobs. It would be good to have an option to run it within a few minutes with 100,000 servers. So I don't think we have seen that kind of model, except for some startups and things like that. But I'm not sure that model is there yet. But it's something definitely we need to put in place.
At the risk of making my Flexera folks angry, I'm going to say that the traditional FlexLM licensing model is probably not the best licensing model for the cloud. We need a cloud-native licensing model. All right. I hope there are some Flexera people out there then. We need a cloud-native licensing model that scales to cloud proportions. The traditional FlexLM model, which is based on your TCP-based connections that use file descriptors and all that, it doesn't scale up very quickly. It doesn't scale up very easily. It's going to be a lot of pain to bring those things up and down in a dynamic environment like the cloud. So, I personally would like to see some discussion about the technological piece of that, and I realize that there's also business implications to that as well, but to me, that's a key enabler for the future for a really scalable cloud for EDA.
Any other questions?
What tool flow would be the first to migrate, or what you're looking at, or the top three?
I think we still think of large, bad jobs, a lot of simulation where you would actually be able to benefit from these kind of things. So I think that's probably going to be the first area. Functional simulation is a very popular internal application that we use internal clouds for. And so I think that'll likely move or at least burst the peak capacities over there. And then maybe circuit simulation will be another area. For the rest of the back-end tools, I think the moving data back and forth, or the capacity, the generation of huge amount of extraction, that will all just take its own time. It will not be an easy one to transition. But I think lightweight simulation where you have synchronized source code, I think you can manage that.
So the interesting thing about that, I agree that simulation would be a good one, but actually some of the back-end tools actually have a lot of promise, because with simulation, or at least what I've found with simulation, is engineers will continue to simulate until you remove that computer from their cold, dead hands. And in a cloud model where you're paying by the minute, that may not necessarily be ideal from a cost model perspective. On the other hand, when you're at the back end of the flow where you've got a limited number of runs, they're defined, they also happen to run on some of your really large memory machines. If I can avoid having to go out and buy a 1 terabyte server for the period of 1 month or whatever that I need it for, there's some goodness to that. Now the flip side is that you're talking about a lot more data than you are typically in a simulation flow. So there's trade-offs.
So we already have customers using the cloud for full flow, the mixed signal flow. We've got a lot of interest on certainly simulation, both circuit and logic simulation. Those are promising categories. Library characterization is another good one that can scale really broadly. I think the interest is there for a lot of the workloads. What's sometimes lost in the conversation about cloud and maybe utilization overall is the cloud has a very subtle benefit, and sometimes it gets compared to the transportation model of, you can have a ride, you can rent a car, you can take a taxi, or you can buy or lease it, and the discussion centers on utilization. But that's a little bit misleading. The utilization just reflects that the engine's running. It doesn't say anything about the utility of the vehicle. And with the cloud, you can have a bus when you need a bus to get 40 people from Moscone somewhere across the town, or you can have a little two-seater if you were going to take laps up at Infineon Raceway. And you only pay for the exact utility that you want. So there's multiple layers of benefit to the cloud and matching the workload to the cloud.
Yeah, that's exactly, I think Craig hit the point that I was going to make is, as we're looking at the tool flow end to end, there's a whole host of VM sizes and configuration types across the platform that can be deployed when you need it. So all the way up to 4 terabyte or larger machines or turbo optimized SKUs. And so depending on the job, you pick the right tool. And sometimes you pick the tool only for a short period of time, like getting an Uber from here to there. The other times you pick that tool in a 3-year reserved instance, for example. So that's effectively like leasing a car for 3 years. And you can do both of those models in the cloud.
Go ahead and ask.
So to use your analogy about buses and maybe like Ferraris, if I buy a license today at an EDA, I get to go 180 miles an hour. But in the cloud, I'm running in a bus, so I'm paying for that license amount. Are there things or schemes you guys use to address that? Yeah. So my question was to follow up from your analogy. If today, if you could do it to transportation, if I buy a bus or if I have a Ferrari at my office today, I pay the same price for the licenses, right? So the Ferrari, I get much better utility out of it, right? But in the cloud, I can get scale. What kind of things do you guys do to sort of address those problems?
Yeah, so it's always good to try to stretch an analogy beyond its useful intent. So let's say you had a red bus, and it's I think part of the utility I'm describing isn't that you don't always necessarily want a Ferrari. You do want a bus for certain use cases, and those are workloads that match the design flow. So for something that needs to be screaming fast, you might want the license for the Ferrari. We have got to make the licensing work so that it matches the bus as well as the intermediate family car or whatever the equivalent is. And each tool has its value proposition. It has its deployment possibilities that match use cases. So I think a deeper discussion on the specific instances will maybe allow us to come to a good alignment with our customers.
So I'd like to address that in a slightly different way. So let's go back to simulation, right? So typical use model for simulation today is that an engineer will, at the end of the day, they'll fire off a whole bunch of simulations, and maybe they'll check before they go to bed. Maybe they'll just let them run all night. Then they check the next morning, and maybe they'll get 2 or 3 turns of their simulations. But in a cloud type model, the way that you would really want to do that is that you would just want to run all your simulations at once, and you're time bound only by the longest simulation in the whole suite, right? And so now, instead of going over 6, 8, 12 hours, however long it takes, because you're limited on either cores or number of licenses, maybe my longest run is, let's say, an hour, okay? Well, let's say that the cloud model, you're running on something that's slower than your Ferrari that you have in your own data center, and let's just say that it's 20% slower or something, right? You're still going to be finishing all of your simulations in a little bit more than an hour, as opposed to 6 or 12 hours or whatever it is, and you can transform the amount of productivity that your engineers can have by doing that. And so we get really bound up in the performance aspect of the single-threaded application, but really we should be thinking about the overall throughput. And the cloud lets us focus on the throughput, but the licensing model, again, the licensing model needs to be adjusted to fit this new reality.
So based on my experience, if you have infinite computing power, I think you're still limited by the quality of design and how much simulation you run before you hit the first bug. And most of the time is spent in debugging all the simulation. So if I run, whether it's 100 or 1,000, early part of the design, I think I'm broken. So it doesn't matter if I have infinite amount of computing power because I'm limited. So the application of running simulation when you want to run thousands of simulation is only valuable towards the end of the project. But most of the time I'm limited by how much I debug, and how do you want to address that? That's one part of the question. Second one, is the demand coming from the product teams or the IT to migrate to the cloud?
I would say kind of bit of both. Let's say ideally there was no IT or infrastructure on-prem, and you only needed it towards the end of the tape out, then you would only need to use it at that. You don't have to have this huge data center, a lot of cost, a lot of real estate, a lot of things like that. I think it would be ideal in that case, and a lot of startups do that, is that they just do very small compute on their laptops, and then when they're ready, they go to the cloud. I think that would actually work much better. When you need a lot of capacity only for a short period of time, I think cloud is probably a better solution. So in a sense, the scenario you're describing is probably a little better for simulation. Most of the time you're debugging. Certainly debug tools, debug technology would be very beneficial to shorten the time to tape out. But from a compute side, and we have seen both sides. I think in order to take advantage of the cloud, we have shown interest from a design team. Of course, the IT team is also interested in seeing how that scales, how that benefits the team. But we have to always keep the cost in mind in that sense.
So overall, I think, again, I would go back to my earlier point around the cloud is starting to become a lot more mainstream. So it's going beyond the peak shaving type of scenarios where, we sometimes feel it's the starting point. But we clearly see there's business models that adapt all the way from peak shaving all the way to running base applications and everything in between. And so with that, we're seeing a lot more wholesale enterprise adoption across IT and business apps to the cloud. And every industry and every company is its own point in the journey. And so I don't think it's as much of a, is there one right solution for every industry or company? That's absolutely not the case. And so from our standpoint, what we are doing is we're building the cloud holistically to be able to run the entire scenario end to end. And at the same time, we know many of our enterprise customers still prefer to run a portion of their jobs or many jobs on premise. And so we have a strong on-premise and hybrid solution along with it. So depending on when the industry is willing to move back or stay hybrid across the two, that we want to be part of the journey with that.
Yeah, I think Mushtaba's nailed it there. We spend about the first 10 or 15 minutes of every conversation about cloud figuring out what the other side means when they say cloud, because it's quite nuanced. And once there's an understanding of what the intent is, and sometimes that intent is to be in a hybrid model. Other times the customer wants to potentially do everything in the cloud, and we've got customers who've just decided they don't want to do their own IT or CAD anymore. Or is it something in between? And so whatever we do, we've tried to have enough flexibility that you can find within the portfolio something that will meet your needs.
I was going to also add that certain applications that I think we can add to that. Let's say we want to have certain special machine learning applications, and only certain cloud providers are providing those kind of things that are adjacent technologies that I think also pull you into the cloud. That's also happening because a lot more people are investigating machine learning, some natural languages, and there are only certain cloud providers that provide that. And so you kind of have to be adjacent to those things, and that is also pulling us in that direction.
Okay, so I want to ask a question that's a little more technology related. So most public clouds were designed mainly with web services in mind. Default storage on the cloud is object storage, right? However, EDA tools by and large look for a POSIX file system. So basically, what solutions are there right now that address that? And basically, what do you see needs to happen, if anything, to tools to basically make them more cloud friendly?
So I guess I'll take that one first. So you're right. And like I was saying earlier, as we started to go work more closely with the industry and getting the requirements, we follow the same blueprint as we do for any industry, understand what the technical requirements are. And sometimes we'll come across a scenario which is not well suited for the cloud at that point in time, and we'll be transparent about that. In this scenario, we have been looking at the pattern of HPC scheduled workloads and massively parallel applications. And they've shared a common blueprint across EDA to upstream oil and gas simulations, to scenarios in finance and the health industry. And so we've been looking at building out our portfolio, both through the VM sizes that we've got, accelerated networking options in our portfolio, but we bought two pretty fundamental startups over the last year. One is called Cycle Computing, and I've got some colleagues sitting here from Cycle Computing, and that technology really focuses on both hybrid and cloud-native HPC cluster orchestration and management. So that is one that we've sort of integrated in, and it's a portfolio for our EDA solution. The second is Avere, which we now call Azure Avere. And Avere really provides a high-performance, scale-out type of NFS file storage system that, again, can sit as an appliance on-premise and enable burst to the cloud, or sit on VMs in the cloud. So what we're doing is, as we kind of go work with the industry, we identify what the blockers are. We also find out what are the common tools, such as IBM LSF, and then just make sure that our end-to-end tool chain can support that. But beyond the basics, Aman made an important point of, once you move to the cloud, there's a lot more that's available, such as the cognitive services, ML, AI, and increasingly IoT for enabling sensor-driven real-time analytics. So those are more forward-looking innovations that are then possible.
Seems like EDA is essentially a database that gets endlessly modified and manipulated by all of these tools along the line. And object-based storage is ideal for sort of a Netflix model where you've got the same thing that's not really being changed. So in this case, I don't think it makes a lot of sense for the EDA side to try to redesign the file infrastructure. One of the key benefits is reuse from generation to generation, and all of your file systems, if all of a sudden there was a discontinuity with the underlying storage mechanism, I think it would be quite disruptive. So far it hasn't been a limiter. We've been able to support using the cloud infrastructure that Mustafa's talking about. So I think there's a way forward.
I have a slightly different take on that. I do think that at some point, we have to embrace those other technologies and just realize that NFS has taken its course. It's gotten us to where we are today, and is that really the technology that's going to get us where we need to be? But you're right that will introduce a discontinuity from the past. And actually, I think that EDA, if you look at EDA startups over the last decade, it's not nearly what it used to be. And I think that this week we've got one here, Metrics.ca. They're a cloud-first EDA startup, and personally, I actually think that that's where we're going to start to see the next round of small EDA companies come in. It used to be the big guys would have their end-to-end tool flows. And then you would have a small startup that would come in and would fill some specific need. They would get to be a specific size, and then someone would buy them up, and the cycle would begin again. And when it comes to the storage aspect of all of this, I think that that's where we're going to see potentially a new wave of EDA startups, which would be a very welcome thing. But we're at the beginning of a transformation, and that's always a very painful time because no one's really figured it out yet. So I think that we're in for a few years of volatility as we try and figure out what the right technology path is going forward, whether it's trying to extend NFS into an object store world, or whether we bite the bullet and make that transition. If you were here earlier today, you heard the IC Managed folks make the claim that you don't have to choose anymore, that they've got that figured out, and that looked like interesting technology. And there are several other folks like Avere, for instance, is one, and there are places like Elastifile and others who offer storage services that will help you to sync your data into the cloud and provide high performance access for them. So it really is, storage is probably the Wild West right now of cloud, in my opinion.
So what do you see? So what kind of EDA design work do you see in the cloud right now? What benefits do you think the cloud will bring to IC design in general? And what do you think the next steps would be in terms of tools, resources, services do you think that the industry needs?
Yeah, I think we've hit some of this already. I mean, anything that's batch oriented that benefits from scale is a good target. In our case, we a few years ago have undertaken some re-architecture of our products. So on the sign-off side, for example, on the digital front, we've scaled our timing analysis, our power analysis, and even our QRC or extraction technology to be highly scalable. So those things will use 1,000 CPUs now, whereas maybe 5 years ago you wouldn't find hardly an EDA tool that could use more than maybe a dozen processors effectively. So it's a combination of the EDA side embracing an architecture that can utilize the scale, and then also taking advantage of tool areas where you can actually just benefit from breaking the problem across many servers. And so the early adopters for those kinds of models are where the tool makes sense. For our Cadence managed customers, they're, as I mentioned earlier, they're doing entire designs in the cloud, so there is no limitation.
So from our standpoint too, yeah, we see customers either moving or trying out a whole host of tools in the cloud. To Craig's point, some are more architecturally friendly to cloud right now, others are not as much. An area of interest internally, we have a quantum computing team at Microsoft, and they've been heavily using the cloud. And in fact, I don't know how many of us here are familiar with quantum compute, but the size of simulations is pretty staggering and is going to grow even, just continue to grow over time. And so that is an area where cloud can be a real accelerant to the design cycle.
I wouldn't call it strictly EDA, but we have almost 2 million units or 3 million units shipped every day. We have a lot of test data from that. We do a lot of learning from that, and then we tend to use that, for example, improving yield on the next product or figuring out our entire supply chain and trying to figure out where the problems could be. Is it somewhat related to EDA? We've used some of the tools in the past from the EDA industry in that space. So just the fact that we have, and this is all being done in the cloud. So a lot of these sort of near engineering applications solutions are being used to learn and apply to engineering solutions. So we've seen some of that. And of course, we are exploring ourselves many areas around verification.
Okay, question?
Hi, this is coming back to the licensing as well. At present, we've got sort of like one simulation license and we buy a certain number of cores. And then we create the VMs accordingly to how we want to solve a particular problem. So what do you think is actually wrong with the present licensing system, and what do you think it should be?
We have a limited amount of time to go over what's wrong. Just kidding.
Too high.
No. So, the problem that I see with the licensing model is partly technological, because the current Flex model, in my opinion, doesn't scale to cloud scale very easily. I would love to see a managed service, a license endpoint, if you will, that is something that's native in with the cloud providers, and something that's cloud agnostic, not something that is specific to a certain cloud provider, but something that matches with what your computing model is. the current flex-based model matches our current computing model because it's based on a time and number of cores and so forth like that. But there's only a certain limited amount of those things that you're going to buy. And in the cloud, you can scale out so much more drastically, so much more quickly, so much more easily. And the flex model does not lend itself very well to that. And the amount of money that you're paying for those things, it needs to be scaled to go along with the benefit that you're getting as well. So,
an analogy comes to mind from how Derek's explaining it, and sometimes if you see one of those collector cars with the license plate called horseless carriage on them, I think that's where we are. Like initially, the motorized cars started out as horseless carriages, but that was not capturing the full opportunity that you can get once you have a motor on a car. And look how far we've come along. And I think that's where we are. Initially, we're thinking about, okay, how do I just take what we've done and move it to a different infrastructure? But I think as we've had the discussion, there's so much more opportunity to then innovate. And we'll get to that too. It's just a phased journey that we'll have to go on.
There are certain public models, I don't know if it's on the website of ANSYS, where they have certain amount of licensing, and then they do have these unit-based elastic compute units that you can buy and then do something similar. So you can look it up.
Any other questions? Okay.
I know it's hard to get a cost advantage, but let me try this way. Okay, let's say you have a license. How long can you run to match? So let's say run for 2-3 months, then it becomes same as the purchaser license. Do you have a number like that? How long can you run non-stop on cloud?
I don't have a number like that off the top of my head. I don't know about.
I have an answer. It's too expensive. Everything is too expensive. So it is something, I think, of course, everybody's prices are different. So you'll have to do an analysis on your own because you have to also amortize the cost of hardware. You have to put everything in perspective and then compute that.
Yeah, I think the cost model really, you have to look at the total cost. But we've been continuously evolving our business models, and so paying by the hour or paying by getting billed by the cent is just a starting point. But you can effectively buy machines for 3-year periods, or even buy even larger amounts. And I think the larger your purchase appears to be closer to a dedicated machine, the pricing adjusts accordingly.
I think that's true of hardware and infrastructure, but the tool licensing is very different. So that's definitely for the EDA industry, this has to be addressed.
Yeah. So I'll let Craig answer that one.
Yeah, I think I hinted at this, that ultimately we do have license models that are shorter than a year, and for most types of functions, it's enough of a period of time to be reasonable. But Aman is pointing to the use model of hundreds of thousands of licenses for very, very short periods of time, and that's very difficult to just jump to. A cloud-based license model is interesting. Part of that might come along with visibility by the EDA providers of the actual usage, and that's something that today isn't available in the current model, but could be very helpful in terms of figuring out what an equitable price is for the use of software for shorter terms.
Okay.
Yeah, so this is partially to the end users, but it's also partially to the vendors on this panel. Is you guys have all been doing work with cloud over the last several years. What's one area that was either surprisingly easy, surprisingly difficult, was a misconception? What's the one surprise you've had over your work, either yourself personally or with customers, in doing cloud work over the last several years?
We have one. We began using the cloud for internal regressions on our software, and it was surprisingly difficult to track down all of the file dependencies that we thought we understood. And so it was just to get it to complete the very first simulation was a much bigger task than you might expect. And so any of you who've had that experience, you find out things about your infrastructure you didn't want to know.
I think probably the most pleasant surprise that I found was the amount of security protocols that you have in order to lock things down, and the visibility that you can get by turning on all of the various logging mechanisms. You can log so many different things about actions that are taken at the API level, and knowing who did what and when, and being able to put alerts in and things like that, and being able to lock down I'm going to use an AWS system, a security group around a machine, or just that kind of visibility and locking down. Being able to easily encrypt data at rest, that's not something that we even bothered to do internally. And to be honest with you, I think most semiconductor companies started off as kind of this very big, wide open space where the focus was on engineering productivity. So keep the permissions as open as possible, let everyone see things. And one of the areas that I think we're all struggling with is that over that same period of time, we started buying IP, and we have to lock it down better internally. And we're all struggling with how do we lock it down internally without killing engineering productivity. And when you take a look at going into the cloud, you have so many more tools that I wish that we had easily implementable inside, and maybe those tools are around, I just don't know about them, but so many more tools and logging available in the cloud than what we have on-prem.
Yeah, I would second that. I think the security aspect was surprisingly better than I expected. What was not expected was the legal side. I think there are so many users, and you would expect that would have been ironed out by now, but the legal side just takes forever to sort out. Our legal people are saying just like cascades and cascades of legal agreements, and so I'm hoping that gets resolved sooner or later.
Oh, okay. Unfortunately, I think we're out of time. This panel's scheduled for 45 minutes, and we're just about there. So I'd like to thank the panelists for their time and their expertise.
Thank you, Richard, for hosting. And just one last quick plug. 7 to 10 p.m. tonight at the Thirsty Bear Organic Brewery, just a couple of blocks away. We're going to have the Monday evening networking event hosted by the Association of High Performance Computing Professionals, and we had several generous donors. I encourage you all to show up and have some tapas and have a couple of drinks and talk about how we modernize EDA infrastructure. Thank you all.